Alright, this is the factoring worksheet that I assigned for classwork one night and told you to go home and work on as well. So we're just going to go ahead and do that. I'll make this a 10-minute video at the very most, and then we'll come back for a second one. So over here on the left I've scanned the flow chart that I gave you, and we'll use that flow chart as a way of working through these problems and talking about that as we go. So over here we start with this trinomial. We see that it's a leading coefficient of 1 up here, and therefore we're going to factor the 6. So we have a 1 and a 6, and we have a 2 and a 3. And we are looking for those that sum to a 1 here. And neither of those will sum to 1, and therefore this is going to be what we call a prime polynomial. There's no other way to factor it besides 1 times the polynomial itself. And on the flow chart here, where you would start was with the GCF, and we'd come down and we'd say, oh, this is a trinomial. We'd look at it and see if it was a perfect square trinomial, which 6 isn't a perfect square, so we know it's not. So we'll come down to the leading coefficient of 1, looking for C's factors that give us some difference of B, and we went through that and we found that neither one. So now we're on to problem number 2. Now problem number 2, what we're looking at is again a trinomial, perfect square trinomial. No, 10 is not a perfect square, so again leading coefficient of 1. Now this time we're also again looking at a square here, so there's an n in here, so we'll treat that n just like we would the m. We'll put it into each of our factors. And so we are again looking for the factors of 10, so we have 1 and 10 and 2 and 5, and those are the factors that sum to a 7. So 5 and 2 sum to 7. So now I'm going to write this as a binomial times a binomial, and I'm going to put an m in each of my first terms, and then the last terms will also get an n because of the n squared down here. And then I need a 5 with one of these and a 2 with the other. And now is when I look at the middle term sign to decide the signs here. When our C is positive, that means that both of the signs in the binomials are the same as the middle term. And so now we've factored it. And you can always go and check it and see that it's the right answer by multiplying it out using FOIL. Now moving on to problem number 3. Problem number 3, again, the first thing I check for is a GCF. Well, leading coefficient's 1, so that's not happening. Trinomial, 3 terms, and is it a perfect square trinomial? Well, 1 is a perfect square, 1 is a perfect square, so it's a potential, right? So I have factors of 1 and 1 here, and then 2 times 1 is indeed equal to 2. So this is a perfect square trinomial. So I'm going to take the root of the first term and the root of the last term, and I'm going to form not 1 but 2 binomials with that, and one of them, actually this is not 2, we really should be writing this in the more simplistic way of 1 binomial and its quantity squared, and then whatever this sign is going to be in the middle here, and so this is a minus b quantity squared, and that's how it factors. Now the next one, what I'm going to look at is I'm going to see that I have no GCF, right? And so now I'm going to see a binomial, and I see that the exponents here and here are squares, so I'm going to be looking at squares, and the differences here, a squared minus b squared, and I need their roots. Oops, the root of y squared is y, and this root of x squared is x. And now I'm going to form not 1 but 2 binomials, one that will have a positive and one that will have a negative. Remember, I'm forming the conjugates there, y plus x times y minus x. Now we could have also rewritten this one as when we ordered it and then seen that the leading coefficient was a negative. So another option in this one is to see this as a negative of x squared minus y squared, and in that case what we would see here is a negative of x plus y times x minus y. And you see the only thing that does is it turns this term here into this term here by factoring out the negative. So either one will do. This one is perfectly acceptable for me, but in our future we may need something more like this, because some of the things that we do with factoring is to use that to cancel, and we would need possibly need the x minus y to cancel. All right, moving on to problem number 5. The first thing I want to check for is a GCF. So 18, 30, and 9, and 15 all have a 3 in common. So that's the first thing I'm going to do. I'm going to take out a 3. And that's going to leave me with a 6m squared n plus a 10mn, and then plus a 3m, and then plus a 5. Now once I've done that, I need to look at this polynomial that's left over, and I need to see if I can factor it. Well, this one has 4 terms, so I'm going to see if I can factor it by grouping. So I'm group 2, and I group 2 to see if I can do the grouping. And so I have the 3 out here, don't forget about it, and then from the first 2 I can take a 2, and I can take an m, and I can take an n, and that would leave me with a 3m plus a 5. And then from the second 2, I can't take anything, so I'm just going to write that as 1 times 3m plus 5. And then once I have a 2-term polynomial, there's 2 terms, one there and one there, I can see that I have a GCF in each of those terms. So I'm going to write my GCF that I started with, and then I'm going to write my GCF 3m plus 5. Now one of the things that you want to make sure that you realize is that you're just writing the GCF down, right? This thing right here is the GCF. So just like when we wrote the GCF before, we wrote GCF of 3 out here, it's just the same thing. And then we're going to get prepared for a 2-term binomial that comes from what's left here, 2m, n, and what's left here, just 1, so that we don't get confused and we don't accidentally write 3m plus 5 squared, because that would be incorrect. But I see a lot of students doing that because what their brain's telling them is that you had 2 3m plus 5, so you would need those squared. But again, that's not correct, because what you actually had was the GCF. And just like when you wrote the GCF of 3 out here, you didn't write 3 to the 4th power, did you? The same thing here. This is the GCF, 3m plus 5, and so you wouldn't write 3m plus 5 to the 2nd power. You're just writing that GCF, and then you're writing it times the polynomial that's left after factoring it out. Now moving on to problem number 6. Problem number 6, there's no GCF, so I move down to binomial. So binomial, and I need to know is squares or cubes. Well, x squared, that's a square, and 25, that's a square. And then I see sum or differences. Now, I think my little worksheet got cut off here for squares, and that should say the sums. And the sum of squares does not factor. The sum of squares is what we call a prime polynomial. So because there's no GCF in this, the only thing we can write on then this is prime. And on the sum of 2 squares, I often see students incorrectly give it to me as the conjugates products, but that is incorrect because the conjugates come from when this is a difference. But the sum of squares does not factor, it is prime, unless of course it had a GCF, but we didn't. Now this next one, this one's a little bit more difficult. We have, first of all, 1, 2, and 3 terms, and you can see that because there are the signs that we can see that separate our terms. Remember, anything in parentheses is a present. We can't see inside it. And so we have 1, 2, 3 terms. And in each of those terms I have a GCF, and my GCF in this case is x minus 2. So again, I'm going to write that GCF down, and then I'm going to get prepared for a 1, 2, 3 term polynomial, right? And then I'll put the signs down so I'm prepared for that. So when I took the x minus 2 out of this term, I was left with 3x squared. And then when I took the x minus 2 out of this term, I was left with 5x. And then when I take it out of this term, I'm left with the 2. So now we need to look at this trinomial and see if it can be factored. So I'm going to look at the factors of 3 times 2, and that's 6. And so 1 and 6, or 2 and 3. And I need those factors that give me a difference of 5. Well, 1 and 6 is indeed the difference of 1 and 5. So we can do one of two things. We can either factor by grouping, or we can try to get the factors of 3 and 2 to give me that product. I'm just going to go ahead and do that one. So I'm going to say x minus 2, copy it down, and I'm going to get prepared for my 2 binomials. Now the good thing is that 3 and 2 are both prime, right? So I need the factors of 3, the first one, to go here and here. Now I'll need the factors of 2 to go here and here, but I'll need to place them in such a way that my outside product, inside product give me a product of 6 and 1. So if I put the 2 over here, that'll give me an outside product of 6, and if I put the 1 in here, that gives me an inside product of 1. So I have my proper products. And I need a positive 5, so I'm going to put a positive out here and a negative in here. So you see outside is 6 and inside is 1. 6 minus 1 is 5. And so now I'm done with that. And so I can make this look like that problem. All right, that's my 10-minute max I said that I would do, so I will come back and I'll start on problem number 8 in the next video.